I'd like to welcome you to the Agricultural Industry Research Panel. My name is April Mickley. I am the Executive Director of Future Problem Solving, and we are here today for the qualifying problem. Our panelists may not be as familiar in the competition cycle as our students are, but this topic is their first competitive topic of this season. They likely have already completed 2 practice problem topics, so this is their third topic for this season. The topic is going to be introduced in just a minute, but I did want to remind everyone of our community expectations. We will be recording this. There is a chat feature and there is a Q&A feature. Our student advisory group will be monitoring both sites, but we would like everyone to please make sure the chat feature is used to discuss items related to the panel. Maybe you might hear an interesting fact that you didn't know before, or a fact comes up that you'd like to know more about. You'd like to share that with other colleagues on the call. So the chat feature is truly about the topic and things occurring in the chat. The Q&A feature is easy to remember because it's questions for Q&A. If you have follow-up or new questions for the speakers, please put them there. And I will ask everyone to please give our student advisory group and the questions coming in some patience. Sometimes the questions come in the Q&A that are repeat questions, and our students are trying to make sure they have or haven't asked those questions yet, and sometimes there's some overlap. So we'll just be very respectful and kind if we get duplicate questions, and we're going to do the best we can to fill this hour with some really great information on the topic from some experts in the field. Trudy, you have a question? I see you just raised your hand. Trudy's one of our coaches. I don't think, Trudy, you can actually speak. So if you could put that in the Q&A tab or the chat tab, wherever it's appropriate. Okay, we do have someone letting us know, one of our panelists, that the chat is disabled for participants. Perhaps Zoom updated since the last time we looked at the various settings. We do see that the Q&A is working, so we will move everything to the Q&A for today. And I apologize for not catching that change before we got started today. At this time, I am going to turn the session over to the true coordinators of this event, our student advisory group. They will be introducing themselves, but they are the ones who have taken the initiative and the leadership to reach out to experts and provide them to all of our future problem solving students today. So my appreciation to them for their leadership, their initiative, and their professionalism in making this session today happen. So thank you to our students, and please introduce yourselves to the group.
Hello, my name is Brian. I'm one of the research directors with the FPS Student Advisory Council, and I am part of the Washington State affiliate.
Hi, everyone. I'm also a co-director of research, and I'm part of the California affiliate.
Hi, everyone. I'm Trevor. I'm another one of the research directors for the Student Advisory Council, and I am from the Connecticut affiliate. And for those of you who are brand new to the topic of agricultural industry, we have a brief overview of the topic. If we could go to the next slide.
Okay.
Awesome.
Real quick, just to introduce myself and Vedika. I think Vedika's having some connection issues.
Yeah, I'm so sorry. Hi, my name is Vedika. I am the executive coordinator of the Student Advisory Council. And on behalf of the Student Advisory Council, I'm so happy you guys are here to see all the work that our research committee has done.
I'm Mahi. I'm the vice executive director of the Student Advisory Council. And yeah, I'd like to turn it back over to Brianne, Cyrus, and Trevor. They are our amazing research directors here on the Student Advisory Council. Thank you all so much for joining. and over to you.
So on the screen, you see a brief introduction of the agricultural industry topic. And one major question within this topic is how can the agricultural industry adapt to feed the world's growing population while considering sustainability and factors that influence crop viability, production levels, and profitability. On behalf of Future Problem Solving, we are honored and excited to introduce our three panelists today, Dr. ChengCheng, Dr. Don Stoeckel, and Dr. Shamim Ahmed. Thank you all for taking time out of your busy schedules to talk to us today. They will be discussing their experience with the agricultural industry and the future of the field.
So we have reviewed the questions that you all have submitted and compiled a list for our question and answer session. If any new questions arise during this session, feel free to put them into the Q&A function and we will try to answer them if time allows.
Okay, and before we begin with the Q&A, I'd like to give each of the speakers just a brief opportunity to introduce themselves to the panel. So I guess we can start with Dr. ChengCheng Fei, and then move on to Dr. Stoeckel, and then Dr. Ahmed.
Okay. Hi, I'm ChengCheng Fei. I'm currently the assistant professor of agricultural economics at Texas A&M University. My research is about climate change and agriculture. I'm doing the economic evaluation for that part. Okay, thank you.
Hi, my name is Don Stoeckel. I work for Cornell University out of New York, but I have a national position based out of Columbus, or I'm sorry, I'm not in Columbus, Ohio anymore. I am in Minneapolis, Minnesota now. And after having spent some time in California, so it's nice to see people from all across the country. My research has historically been in fecal material. It's been about poop, because we all do create such substances in the work that we in our day-to-day lives, and the animals do so also. So how do we reuse that fecal material? How do we protect our public health from when we are using the fecal material? And how do we protect the national resources have been my research focuses. So over to you, Shamim.
Hey, good morning, everyone. Probably good afternoon also for some people. Hi, this is Shamim Ahamed. I'm working as the assistant professor in the Department of Biological and Agricultural Engineering at UC Davis. In terms of my research, I mostly work on the indoor farming, like any protected cultivation, like greenhouse, indoor vertical farming. But my lab mostly focus on the precision control, monitoring, integration of the renewable energy system, and the optimization and modeling of the indoor microclimate of the protected cultivation system. And I'm happy to be here. I think it's going to be a very good discussion with lots of participants from different parts of the country. Thank you.
Okay, thank you all the panelists for those kind introductions. So without further ado, we're going to jump into the Q&A. So just for our panelists, any one of you can jump in when you feel like it, and if you don't have the expertise or wouldn't like to answer a question, feel free to defer. Okay, so our first question is just a more general one. It is, could you speak briefly about your experience with researching the agricultural industry? What inspired you to enter this field, and what has kept you engaged with it?
Well, I suppose somebody has to go off mute. Shamim, do you want it?
Yeah, I can jump in.
Okay, great.
Yeah, so the motivation for me to kind of come to the ag research, like my background also, like my bachelor, everything is from agricultural university. I think in my country, like sometimes the university is kind of very specialized, either engineering, ag, or the general science. So I did my bachelor from agricultural university in ag engineering program. For sure, that's basically kind of motivate me to do the research in ag. But my father was a farmer, and I grew up in a farming community, like, and from that, like, I have to some point some passion for the farming, and from that early childhood motivation to then the getting opportunity to get admission in one of the top agriculture university in the country. And during the time when I met with my teacher and the different subject matters that I was taking the time, and that helped me to kind of fixed my future career as a researcher in ag area. Yeah. So that I think I know like it's a very general statement, but that's I would like to say kind of motivation and for my research in ag.
Well, go ahead, ChengCheng.
Thank you, Don. For me, it's kind of easy. Like for the first time I learned about mathematical programming, I feel I really like this method. And then I talked with my advisor, and he's doing climate change and agriculture research topics. I got into the field and start working on that. I really like it, and then I keep motivating myself to working on these topics.
And I came into it from wishing to understand as a young person how the natural world works and how the human population can live in harmony with the natural world and natural processes. So I actually became a microbial ecologist to think about nutrient cycling and fate and transport of pathogens. I didn't start off in agriculture, and I haven't done research in agriculture. What I do is education in agriculture, because what I learned when I was working with fecal contamination having to do with cities and also the agricultural environment, and when they got into the natural resource waters, was that much of the work that the scientist colleagues that I was working with, the researchers that I was working with, much of the work that we did was shared amongst ourselves and shared with policymakers, but the people who were making decisions were not using some of those research results. So I got into agricultural extension at Cornell University because of the need to bring scientific knowledge and science literacy to decision making in operational situations like on the farm.
Awesome. So what are some of the most substantial developments that you've seen recently in the agriculture industry? And how do you foresee these developments impacting the industry in the future?
Yeah, that's a good question. Like in terms of the recent development, I think from my research perspective or like my understanding in the ag, most important things people are more focusing about the sustainability aspect, like climate smart agriculture. What are the different technological innovation from very fundamental plant science to very high level precision agriculture, like engineering concept, like how this technology can helps to improve the sustainability of the agriculture. Because although like in the developed country, the agriculture are more with advanced technology, more and a sustainable practice, but still the contribution to the climate is significant from that perspective. Like from people are focusing on from more fundamental like gene editing things to make some crops that can have like drought tolerant capability to like kind of very high tech machinery that could be kind of integrate with the renewable energy system to minimize that impact and also to minimize the resource use from high level precision agriculture. So I think that's one of the biggest aspect we can see, like to see the dimension how the agricultural practice or the research is changing to the climate smart aspect.
Yeah, I agree. Like recently, the government gave subsidies to the climate smart agriculture practices. And also the precision agriculture technologies are really amazing. Like in general, the national average yield of corn is about 200 bushels. But if the farmer use precision agriculture technology, they can get a yield about 400 bushels per acre, which can increasing the efficiency of resources usage dramatically and can produce sufficient food for the future.
I think those are both great answers, and I'll mop up with by just summarizing, I think, a little bit more than saying anything new, which is data availability and data analytics really lead to precision agriculture, which makes a huge difference in our ability to increase yields and also be climate smart about the things that we do. One of the things that I see when I work with the farms more directly is these things also contribute to automation and scale and less reliance on labor and ability to manage and control the environment, or at least adapt to the environment as it is. So I think it's a much smarter process now than it has been in the past, and it requires a lot of knowledge.
Yeah, I heard the farmers can just watch the soil moisture level from their smartphone, and they can get a lot of information when they're sitting at home, and they know the information, what happens in the field.
Cool. Thank you all for the
I
insightful
also would
answers.
like to add one thing, like in recent couple of years, I think there is another research area or a kind of getting more attention. It's called the biocircular economy. So if you think the agricultural industry is one of the top, I think, sector where the huge amount of byproduct happen, like from production to processing to the consumption. So from that perspective, I think the biocircular economy could be one of the biggest area in terms of research, and in future practice should be execute and implement to also reduce the environmental impact, and also to implement the climate smart practice for agricultural production to the consumption level.
Okay. So our next question is a frequently asked one. I see some people are also asking in the chat. And the question is kind of, can you all touch a little bit about how does climate change impact agricultural productivity and crop diversity in 2025? And some people are especially interested in animal agriculture as well.
I can give it a try for that one. First of all, I think it is a little bit hard to predict the production and crop diversity also in 2025 in the short period. First, for atmosphere science, it's hard to predict the weather in the short period. But one thing we can talk about is the ENSO impact, which is the El Nino and La Nina impacts. So this year, as predicted by NOAA, it is a La Nina year in the spring, but after spring, it may turn into a neutral, which is saying the temperature in the sea, near the sea surface, near the equator in the Pacific Sea, will be slightly lower than the historical average. When we have a La Nina year, it typically means we will have a stronger polar jet stream, which will make the east part of the country be colder. So we just saw the strong winter storm has happened. But for the southern area, it is typically being drier and warmer. So unfortunately, it will not help the current fire in California. Well, as the U.S. agriculture production is mainly from the Midwest area, so having a La Nina to neutral ENSO impact may not impact too much on the national production of the major crops. But yeah, so far it is really hard to do the prediction for that. But overall, climate change is making the southern area much more hotter, which will reduce the general production of the crops. But it makes the northern part of the country being much warmer, which reduce the cold stress and increase the crop productivity. And it's similar for animals. So for like our research already found for dairy cows and beef slaughter animals, we found the lower humidity level and the lower temperature can increase their productivity, but the higher humidity and temperature reduces their productivity on the other side.
Yeah, I can add some things like I think the climate change is one of the biggest issue for agricultural sector. Like I think the agriculture sector is I think the one of the top that being impacted seriously from climate change. And very recently the UC Davis researcher published that like California considered the food basket of the USA, right? And they predict that if the climate change continue like the way it's going on, so by 2050 or end of this century, like the California will lost 1/3 of their production. So that's could be a biggest threat. Okay, like if that's things really happen, and then that's gonna be a big threat for our food supply chain. So from that perspective, like the area that I'm working, the indoor farming and control environment ag, I think especially like the region where the climate is a big issue to grow the crops or for the year-round production. From that perspective, we need more protected cultivation system to make sure that our supply chain or the food supply chain is not being impacted, because if the climate change really put big threat, then in that case we need to find the alternate option to kind of grow the food to meet the food demand for the large number of the population, not just from US perspective, from the whole global perspective. But I also would like to mention that the indoor ag is not the solution for everything. This could be a supplementation beside our traditional agricultural system to ensure the food security despite having that challenges from the climate change.
And I want to just be clear that the things that I say are from the perspective of specialty crops, fruits and vegetables, not the typical row crops of corn and soybean. So I don't want to be confusing to anyone as I make a few comments that affect especially specialty crops, but they might also affect the agronomic crops as well, which is it's hard to say what will happen in 2025 other than to say we can expect to see incremental changes along the trend that we have been seeing. As Shamim says, we're seeing more of a trend toward indoor farming or controlled environment agriculture. Why? Partly because people, especially for specialty crops, and one of the reasons is because people are more concerned about water availability and water quality. And the work that I do with produce safety, one of the big unknowns and one of the big gambles any grower takes is that no one will get sick from the food that they eat, because one outbreak like romaine lettuce can be devastating to an entire industry for many years. There's still repercussions from 2006, before many of you were born, the spinach outbreak that occurred near the Salinas Valley of California, and the spinach industry still hasn't fully recovered. Hundreds of millions of dollars in cost to the industry every time an outbreak happens, and controlling the environment both to protect against wildlife intrusion and fecal contamination in that way, managing the water and the quantity and quality of water that's being used, and then bringing it to climate, having some buffer and some control over the growing environment. It's not the thousands and thousands of acres or millions of acres of row crop solution, but for our specialty crops, I think it's a strong factor that's driving us toward in that direction, as Shamim said.
Awesome. So our next question is coming directly from the Q&A function. So thank you guys for utilizing that. And it is, how does less diversity of crops in the agriculture industry impact the soil that's being used and the biodiversity of farms as a whole?
I'll start off from an ecological perspective, that many farms tell me that their wealth is not the crop that they sell every year. It's the soil and the richness of the soil, and that allows them to grow the crop every year. So when we have a continuous monoculture crop on one area of soil, if it is not managed to promote diversity, to promote a robust soil, a healthy soil, microorganisms, community of microbes, then you have less nutrient cycling, you have less nutrient retention, you have less organic material. So I'm not saying it can't be done to grow one crop over and over again, but we do have to have a care to manage the soil effectively, so that we're not one-trick ponies, that we're able to be robust and adapt to stressors that come in, which most things that I have read say that if you have one crop, you only have one thing that you're focused on, you're less able to adjust to stressors, whether those stressors are climate or pest pressure. And I think ChengCheng has some more to say on that topic.
Yeah, from economic perspective, we have to do it's kind of two parts. First, we all heard the story, don't put all of your eggs in one basket. So when the farmers has a diverse income sources from different crops, then it is more resilient to climate changes. That is one part. The other part is, yes, from an economic part, land is one of the most important source income for the farmers. They are getting that agriculture is a perfect competitive sector, so they don't have much bargaining powers for what they can, like the price of the products they can sell, but they can get returns from their land and from their labor. When their land quality is decreasing, then the land rate will be decreased. The land rate comes either from the return of the crops or comes from the farmers lends the land to others. So from that part, the farmers start using like winter cover crop and many other strategies to increase the soil quality, so ensure they can have a higher yield from their cash crops, or they can lease their land to others in higher prices. So those two parts will protect the farmer's income.
Yeah, I can add some things, although that's not my expertise, like the impact of the same crops for long term. So I think it's depend on the industry. Sometimes like some industry that kind of completely depend on the one crops, like for example, vineyard or similar kind of things. So from that perspective, some people do like if you grow some things and then you can leave that land like without any cultivation for a couple of months, and that helps to kind of rebuild that things. But for sure, like if you some people also do the cover crops like to help that impact minimization. So like so this kind of practice people try to do, or people try to investigate from research perspective. But that's I think not my area to make more comments, but I think people are trying to see that what could be the possible way to minimize that impact.
Yeah,
Awesome.
in the northern
Sorry.
area of Texas, just one add-on. In the northern area of Texas, it's pretty windy in the high plain area. So adding a layer of cover crop can reduce the soil erosion and then increase the soil quality. So
Okay, thank you. So our next question is also from the Q&A feature, and it is, what exactly is precision agriculture, and how has it impacted the productivity of the agricultural industry?
So I threw into the chat into the response because we have we all have our idea of what precision agriculture means, and it's smart use of data in very in a very rigorous way in order to improve productivity. And so in the chat is some subject matter experts from USDA who gave their definition, which I won't read. You can read to yourselves. But I think that it has made a huge difference in both the ability to automate by using GPS to use machinery that is connected to GPS and data sensors to reduce labor costs and also improve efficiency. So I think it has been a real game changer for many farms. And from an ag econ perspective, I'm really looking forward to hear what the economic benefits have been.
yeah, I'm going to give a story I heard. So for precision agriculture, the farmers can use the satellite data and also GPS data, and also they have a lot of sensors put into the fields, and also they use the drone to take pictures. So the story I heard is when the time to put in the fertilizer, they use GPS to guide the tractor to put in the fertilizer underneath the soil. And then when the planting time, they can put the seeds exactly in the exactly same area where they put fertilizer before. So the crops can use 100% of the fertilizer without any waste. That will reduce the cost dramatically and also increase the crop yield. And they even do, like in the Midwest, they do combined field of corn and soybean. And soybeans is lower when it's material, but corn is way much taller than soybean. So they put one area of the like one area of corn, one area of soybean after the calculation. So both corn and soybeans can get the maximum amount of sunshine, which can increase their productivity. So this is kind of two stories I heard the farmers are doing when they are using precision agriculture. And for sure, they use the sensor of the soil moisture level to guide them. When should they do the irrigation and what should they do for the soil and other management part.
I have a quick question to follow up on that, which is whether as people are applying precision agriculture, do they need more education and intelligence in order to do it effectively, or do they need more expensive machinery to do it more to use it effectively?
I think it's both. What I heard is the hobby farmer or small scale farmers are not able to afford all of the fancy equipment, but the large scale farmers or the farmers not only has their own land but prefer to lend land from others are using those precision agriculture technologies more, so they can have a higher profit margin.
Okay. So I would like to add also one thing, like when you think about the domain of the precision ag, its ultimate goal is to reduce the operational costs through precision operation, increase yield, minimize the resource uses like the nutrient, fertilizers, even the energy. So that's basically the fundamental goal of the precision agriculture. But one of the biggest challenges for any precision ag is the lack of skill and workforce. Like this is one of the biggest challenges in the ag domain. Like you can probably like have many technologies, but you need some also expertise to manage those things. You cannot hire engineer for doing that thing. So it's still we need some technological the workforce to kind of manage that things. From that perspective, I think it's very critical. And I would like to also mention some precision ag application in my area, the indoor farming. So when you think of the precision ag in indoor farming, it's just not to kind of doing the um, precise operation. It's basically just think about it. Like it's you have to kind of with the application of precision ag, you can listen what plant is talking. So because every plant is different. Like even if you're growing lettuce, so every lettuce could be different depending on many other factors. The local environments, the nutrient that you are supplying, the CO2 concentration that you have that particular, or the light environment that you have. So based on that, like if you can really can listen what the plant is talking, either they're in a stress condition or they need some things. So that helps to kind of improve the quality of the crops, as well as you can minimize the resource use. And also, like for any indoor farming industry, the biggest challenge is the energy cost. Energy cost is huge, and that's I think one of the biggest threat for sustainability of the indoor ag industry. So from that perspective, like even if you can really get the understanding, okay, this is the right temperature that plant need combination of others factor, even 1 or 2 degrees Celsius of the temperature, or couple of intensity or couple of degree intensity of the light can significantly reduce the energy cost. So that's you cannot do kind of with the traditional approach like the often controlled system or those kind of systems. So you need kind of very real-time monitoring of the plant with very high level of precision to manage exactly the right temperature as well as other parameters that is required for plant to have the optimal production. So from that perspective, especially for indoor ag application, it's very critical to kind of reduce the operational cost, ultimately the sustainability of the industry.
So you three have made it very clear that there are a lot of clear benefits and opportunities that can be found through precision farming. But are there any drawbacks or any negative impacts on the industry that come from farmers relying on or using this new precision farming?
Expensive. Yeah, the farmers need to have a relatively large initial investment into to get into the equipment and then do the precision farm.
So I would like to one of the biggest challenge that I can see in my domain. So especially the indoor ag is tech oriented, like it's lots of technology involved compared to the open field. But sometimes most of the industry, I would like to see, is not individual farmer like the big indoor ag industry. They're heavily relies on the robotics, automations, the machine learning, data science. The challenge is that like they invest huge amount of money in that sector, and they don't have the real people who know about the agriculture, who know how to grow the crops, who know that like what immediate action you have to take for some unexpected situation. So in that case, it's good that no, you can rely on the automation and robotics, machine learning, but at the end, it's a very complex system. It's not just routine work like the manufacturing industry do, but agriculture is a dynamic system, and it's kind of many other factors could impact and kind of transfer that things easily for the whole production area. So from that perspective, I think complete relies on the automation and robotics and the technology, I think could be a big problem. And that what we can see even in the industry, they're investing huge amount of money for the automation and robotics, but they're not focusing on the growers who know about the plant, who can take some immediate action based on their expert knowledge.
And I'd like to represent a perspective that I haven't heard yet, and this goes a little bit to what Rose has asked in the Q&A also about big farms and small farms, because I think that precision agriculture has a bearing on that. And I think I want to represent more of a social aspect of, if you're going to use precision agriculture, there's some great benefits in efficiency. And if we're going to feed the population of the world, we need efficient agriculture. But what's the flip side? As ChengCheng said, a farm is going to make a tremendous investment every year in accomplishing their goals with precision agriculture. And if things go poorly, that investment doesn't turn out. And so there's an investment that wasn't spent. But also, let's not forget about small farmers and cultural farmers. And I say this because I come out of Ohio and an area where there's a lot of cultural farming, not just the Anabaptists, the Mennonite and the Amish farmers who farm by horse, but also people who believe and do community-supported agriculture, local agriculture, and try to reduce the cost of transportation and improve food security by growing food locally. And for many of those farms, the cost of precision agriculture is out of scope. So I think it's important to acknowledge that precision agriculture can be fabulous in improving our efficiency and creating a lot of food in one spot, but the food still has to reach the people. And if we outcompete local farms who are growing locally for cultural or food security reasons, then we have to consider that as one of the side effects.
Okay, thank you all for your interesting perspectives. So our next question, I hope will also answer some of the questions in the Q&A about pesticides. So the question is, in light of growing concerns about resistance to pesticides, how might livestock farming practices evolve, and what alternative approaches could emerge to ensure animal health and food safety?
I may start talking about crops for pesticide first. So in the US, well, based on my research, I saw two things. Over the time, the total amount of pesticide usage is decreasing over years. It is because of the regulation, because like some pesticides which was allowed to use in the past is not allowed to use now because of the either environmental damage to or the damage to human health. And also because of the technical development, the pesticide is more and more efficient to treat either for the pest or herbs. And don't forget about GMO. GMO has been developed for three parts: drought resilience, herbicide resilience, and also pest resilience. When there is a GMO focusing on the pest resilience, we typically reduces the usage of the pesticide on that part. So then we will have a decreasing amount of the total pesticide usage as well. So based on my research, it is happening, and we are using less and less pesticide, and then it will have less impact on the environment and human health. But I'm not familiar about the animal science.
And one of the pre-questions was talking more about antibiotics in the context of animal agriculture. And it is a significant concern that we may not have all heard. There is such a thing as multiple drug resistance, and strains of pathogenic bacteria, including flesh-eating bacteria, that are resistant to nearly all antibiotics that are currently in circulation in the medical field. So managing the spread of antibiotic resistance in pathogens that can affect humans has a significant impact on human health and the future of human health. So how do we reduce that? Because there is a reason for using antibiotics in animal agriculture, and one option might be to increase the use of vaccines, which could not only reduce the need for antibiotics, constitutive antibiotics in the feed source, but also reduce the shedding of human pathogens by those animals in their feces, which has a produce safety impact. I hope those were the general topics that the person wanted to hear about.
Yeah, and so I would like to add one thing, like again, like if we go back to the importance of the precision ag, I think from that perspective, like especially for pesticide application, or also to minimize the impact of the pesticide application, if you really can perfectly integrate the precision ag technology, that can really can be a big benefit to reduce the impact through minimize the amount of pesticide that people use. Even like symptoms, like if you can early detect the issue, let's say before it's kind of infested the whole field, in that case the precision ag can help, and from that perspective it has a big potential. And also one of the things, like I would like to mention again from my domain, the indoor ag industry. So the pesticide application in indoor ag is almost negligible compared to the open field, because it's kind of very protected and not that much interaction with the outside climate. And from that case, like it's almost like you can think about, like not all indoor farming, but most cases to some point is kind of less application of the pesticide in indoor ag industry.
So, Dr. Ahamed, I know you've been talking a lot about indoor ag throughout this panel, and one of the biggest developments in the indoor agriculture industry over the past few decades has been the emergence of hydroponics. And so we were wondering if any of you could touch on the emergence of hydroponics and how that could impact the agriculture industry, both economically and environmentally moving forward.
Okay, again, sorry, like I'm probably bringing the indoor ag because that's the area where I'm working, but and that's my expertise. Yeah, that's a good question. Like, okay, how the hydroponics can helps to kind of help in terms of economic perspective, climate perspective. Like, when you think about the hydroponics, they have a different approach of the hydroponic, but in general, any hydroponic system is much more water efficient than any open field production. So for example, like if you would like to think 1 kilogram of lettuce, I don't know how much idea do you have how much is the water consumption. It's a water consumption is more than 150 liters for 1 kg of lettuce production. To some point, some people even reported 200 kilogram of water, 200 liters of water for 1 kg of lettuce production. If you just think about how much even in open in control environment ag, depending on what kind of control environment ag, whether it's indoor farming or greenhouse, it's less than 20 liters. So that's like, for example, you can think about in California, the water is very regulated here. So even many farmers right now out of doing agricultural operation because the water is very regulated in California, even in agricultural sector. So from that perspective, like it has a huge impact in terms of the environment aspect, because most of the waters that people use for open field irrigation is groundwater. So if you pump the groundwater, and that has an impact in the environment. The same things like from pesticide application in hydroponic production, as I mentioned, like especially for leafy green, the pesticide application is almost zero, close to zero. So from that perspective, you can significantly reduce the impact of the agricultural production on our environment. From economic, again, it's depend on, it's a very big issue, especially for the industry, like because any crops that you can get from any indoor production, it's pricey than the open field. Now again, it's a consumer preference. Like, do you really open to pay the higher price for the crops that's pesticide free, that has better environmental impact? That's a big issue. And into some point, some people also found that, okay, no, if you grow something in indoor, and if you can provide the right recipe, like temperature, relative humidity, the quality to some point much better than the open field production. So if the people really can think that, okay, no, I would like to get a quality crops or the good quality the vegetables, from that perspective, it has benefit. But at the flip side, like as I mentioned also, the these are the benefit, but the negative side is like it's an energy intensive production system, and that kind of the force to having the higher price for any crops that you can get from any indoor production facilities. So that can be reduced if you can really think about the renewable energy integration and the precision application, and even some more research and development that will help to reduce the cost around, at least not to the level of the open field, but close to that level. So at least it's not kind of double or 3 times higher than the open field. I think it could make a big change to the food supply chain.
Yeah, I wish to do a little bit add on. So for indoor farming, I'm working with someone else on these topics as well. We have 2 more benefits. Dr. Shamim hasn't mentioned yet. So for indoor farming, it is a controlled environment, so it can be near any of the large cities. Then it can reduce the transportation distance, and then we can provide the market with much more fresh fruits and vegetables. And we don't really aim to use the indoor farming to produce corn, soybeans, but it is more for horticulture, for vegetables and fruits. So the consumers, well, all the consumers or agriculture sector, we can get a big benefit from it for with much more fresh and higher quality products. So,
yeah, I also, one of the things we haven't talked about yet is solutions and how policy drives solutions. And this is because there's so much, well, I have seen some attention to stresses on groundwater resources. And California in particular has stress on their groundwater resources, but also many other parts of the country and the world are overdrafting their groundwater resources. So in particular for California, you have the SGMA, the Sustainable Groundwater, whatever, groundwater management restrictions on how much water a farm can use. Do you feel that that's really driving? Is that another potent factor that drives farms toward practices that have more water efficiency, such as CEA?
I would think so. I heard one presentation talking about the water value in agriculture in California. So a strawberry farmer in California wished to pay for over $1,000 for 1 acre-foot of water. But in Texas, the water only weigh about $100, even in the relatively drier area. So there is a big gain from the water resources in California because it is producing like vegetables and fruits. Those products has a much higher value, and the farmers can get a higher return from the water resources. But in Texas, it's mainly the row crops, which has a lower return, so the water value will be much lower. But we are still having the same situation. The depletion in the Oglala aquifer is increasing over the time.
Yeah, come back to To your question, yeah, for sure, the water use is one of the biggest, the positive side that kind of enforce the indoor ag to promote, and especially the region like California where the water is a big issue, like, and it's a pricey too, and also like the extensive pumping of the groundwater that could be a kind of also big threat even for the salinity issue. Like from that perspective, I think the CA or the indoor ag has a potential, but again, as I said, it has also challenges. That challenges need to overcome to kind of make sense, or like from sustainable perspective, because sustainability is not the environmental benefit, it's economic benefit, and also at the same time, the people perception should be kind of positive to the indoor ag, because even I heard sometimes, especially the senior people sometimes think about, okay, the crop that grow in under the sun compared to some things under the artificial lighting, the quality maybe not that much good, but the research found even it's much better than the outdoor production. That's the one thing. And also another aspect is very sorry, excuse me, very important, like when you think about the indoor ag industry, because um, this industry, the practice that we are doing is much different than the traditional agriculture. So in that case, the workforce also one of the biggest challenge in this area, because it's more tech oriented, and the agricultural practice also different. So from that perspective, I think the workforce development is also one of the biggest challenge for this sector to make kind of sustainable production.
Okay, thank you all for your answers. So just looking at the time, I think we're going to move into maybe one or two more general questions for our panelists. So the first one is a pretty broad one. How do you handle communicating complex research topics with the general public? Any tips?
I'll offer to start this one because it was one of the hardest things to learn when I switched from the laboratory bench and the podium at science meetings to talking to people. And that is to know your audience and know what they want to hear. And not one of the challenges as a researcher who is proud of the work that we do is to tell people how amazing you are and what great research you've done and how much knowledge you have. They don't really care. What they care about is the answers to their questions. So number one thing that I think is most important is know your audience, know what they want to hear, and give it to them.
Yeah, I think Dawn made a great answer for this question. I would say I prefer to use examples to explain it, and use the examples the audience can understand. That will be much easier for me.
Alrighty, so our final question is, what skills do you feel students should learn in order to better be prepared for later academia, or being a part of agricultural industry? And what advice would you give to students who are interested in maybe pursuing a job in the field of agricultural industry?
Shamim, do you want to start on this, or do you want?
Yeah, I can jump in. Like, I think, so I would like to kind of share one thing, so like for the next generation people who maybe can think the ag industry as their profession, either in terms of the industry or the academia. So one thing I always feel sometimes when I see some student in the ag industry or the ag discipline, they don't have any exposure to the ag. But I would recommend, at least, like, if there is any opportunity to, if you are passionate or if you're thinking for the ag discipline, you have to love the ag and how to grow the crops, how to take care of the animals. So that's very important, I think, to have better outcomes, or also to be kind of dedicated for this industry or for this academic discipline. So that will be my suggestion for the next generation workforce. You have to love it and you have to think that way. Okay, how much contribution you are doing for the world population? Because food is at the ultimate. This is our prime need for our survival, right? So if you can really make some big impact for this industry, you are doing kind of a big job for this planet and for the human being.
I'll go next then and say that I'm old enough that when I was in your seats in school, we were taught to memorize things and sometimes know where to find things. This was before Google. This was before chatbots. And what I see in my kids and in the people that I work with is you have all the information available to you at your fingertips. And it's so lovely. It's great to have all that information. You don't have to spend so much energy memorizing and remembering things. But you now have a responsibility for knowing what's ridiculous and what's not ridiculous. And so I think the important things for you to learn and understand are how to ask a good question and how to know when the answer is ridiculous. And that comes down to basic science literacy and critical thinking. I think that applies to anything you choose to do. And in agriculture, we're relying, I think that the curve has been even faster in agriculture compared with some other fields of having the information available, such as precision agriculture that we've been talking about. And I think that you can really help people who are generational farmers keep up with things if you can show them, develop those skills yourself and show them those skills so that they can also do those things.
I would say communication is also important. I would like my students to keep communicate with me so I know what they are doing and they know what they should do. It's kind of we are getting the information more symmetric over the two parties. And I think this applies to no matter what kind of field you want to work on in the future.
Alrighty, that was our last question. So I'd like to thank all of you who are watching both live today and those of you watching the recording. And on behalf of the entire future problem solving community, I'd like to extend a huge thank you to Dr. Fei, Dr. Stoeckel, and Dr. Ahamed for their time, for their insights, and their amazing responses today.
Yep, just want to
Thank you,
say
everyone. It was nice to talk with the panels and having great question from the audience.
Thank you,
Yeah, so
everyone.
And I think one last thing just before I conclude, I'd like to turn it over to Vedika to just talk a little bit about the Future Problem Solving Student Advisory Council.
Hi, everyone. I just wanted to really quickly talk about the Student Advisory Council. So we work to support problem solvers around the world, and we make resources like these amazing panels. We make other research materials, newsletters, guides, and we'd love for you guys to be a part of the mission. So in the email, I think after this council, there will be an application link, and we are still accepting applications. So feel free to sign up and email us if you have any questions.